Hello, hello, folks. In this video, I'm going to go over some area basics as well as how to find the area of composite or irregular figures. I'm hoping that a lot of what you see in this video will be review, especially the equations, and then you'll see a couple of examples though that that bring in some other aspects of geometry that we've learned this year. Right. So a lot of these formulas are pretty simple, but there may be some parts that you'll need to pull from your bank of geometry knowledge in order to solve. So I'm in your area equations graphic organizer. I'm going to do everything on the first page except for this one, the isosceles triangle regular polygon, because I'm going to talk about that in a slightly different video, because there's a slightly more complicated formula for finding the area of a regular polygon. Okay, so let's go ahead and we're going to jump right into it here. Okay, so a rectangle and a square. These, again, I'm really hoping that you've been doing this for a long time, right? So remember, in a rectangle, you have a base and a height. Okay, so the area of a rectangle is just base times height. Okay, if you are doing this with a square, so the area of a square, you replace base and height with side and side, right? Because all the sides of a square are the same. So the way that we typically write that is side, whatever the side length is, squared. Okay, so let's look at a couple of examples here. Okay, so my first example, I'm going to use this lovely rectangle that I have right here. So I'm going to tell you that this is 15 centimeters, and I'm going to tell you down here that this is 8 centimeters. So if I want to find the area of that rectangle, it's literally just 15 times 8, which is 120. And then I want to make sure that I use my units here, because I have units in the problem, so you have to give me units in the answer. So my units here are centimeters squared. Okay. Right. Then one more example for you dealing with a square. So this is like a work backwards kind of problem. So I'm going to tell you that the area of a square is 400 meters squared, and I want to know what the side length is, right? So I know then that 400 is equal to side squared. So I need to take the square root of both sides in order to get that the side length is 20, and then my unit would be meters. Okay. All right. So next type of shape is a parallelogram, and we're also going to talk about rhombuses or rhombi here in this one. So when you're looking at a parallelogram, you may remember me referring to a parallelogram as like a drunk rectangle, right? It's literally a rectangle that's kind of fallen over on its side. Okay, so we still have the base down here, okay, but the height is not this slanted value, okay? The height, that line is not straight. I'm going to try to draw this line a little bit straighter, okay? The height is the vertical distance, right, from the top to the bottom. Okay, so this is my height. Okay, so what I want to show you, though, is even though the parallelogram looks different from the rectangle, the formula to find the area is the same. Okay, if you cut off this like excess triangle that you see over here on the left and move it over to the right hand side, you just have another rectangle where the base has stayed the same and you still have the height, right? So just like a rectangle, the area of a parallelogram is still base times height. Okay. Then for rhombuses, if you remember a rhombus, if a parallelogram is like a drunk rectangle, a rhombus is like a drunk square. Okay, so it's a parallelogram where all of the sides are the same. So you can find the area of a rhombus using this formula, base times height. Okay, but you can also use this special formula, okay, which is 1/2 of d1 times d2. You may be wondering, what does the d stand for? Okay, d is your diagonals. Okay, so if you know the length of both diagonals in a rhombus, then you can multiply the diagonals together and cut that value in half, and that will give you the area of that rhombus. Okay. All right, so let's do a couple of examples here. Okay, so my first example is just for a regular parallelogram, where I'm going to tell you that the height is 16 and the base is 10. Okay, so the area of my parallelogram is literally just 16 times 10, which is 160. Now, because I don't have units in the problem, you don't have to give me units in the answer. Okay. All right, let's do one more. Let's do a rhombus example. Okay, so I'm going to tell you that the area of the rhombus is 150. I'm also going to tell you that one of the diagonals is 15. So I'm going to plug that information into my area formula up here and solve, right? So I have 150, that's my area, equals 1/2 of 15 times d2. So what I'm going to do is multiply both sides by 2 and then divide by 15, right? And when I do, I get that the second diagonal is 20. So, and again, just like, that is barely readable. Just like in the previous example, because I didn't give you units in the problem, you don't have to give me units in the answer, right? So just as a reminder, what I did here is I multiplied both sides by 2 to get rid of the 1/2, and then I divided both sides by 15. And when I did both of those steps, I got that d2 is 20. All right. Okay. So let's talk about right triangles. And I'm actually going to zoom in a little bit. I'm going to clear my screen off and zoom in a little bit more so that you guys can see this hopefully a little bit more clearly. Oh, or not. It's not going to let me zoom in anymore. Just kidding. Okay. Well, let's go ahead and look at this right triangle then. Okay, so here, the formula for any triangle, okay, to find the area of any triangle is the same, okay? Like it's exactly the same, okay? So with a right triangle, though, it's just a little bit easier to figure out where the base and the height are. So my base, right, is down here. My height is here. Okay, so if you recall, again, hopefully from middle school, you remember that the area of a triangle is 1/2 base times height. Okay, and if you have never seen this before, the reason for that is because if you took this right triangle and you doubled it and put another right triangle on top of it, you would end up with a rectangle, right? So you have a rectangle, which in the area of a rectangle is base times height. You're literally cutting it in half in order to find the area of a triangle. Okay, all right, so let's do a couple of examples here. Okay, one example, this first one that I'm going to do for you is a pretty basic example where I'm going to give you the base and the height. Okay, so here's my first example. Okay, I'm going to tell you that the base of this triangle is 11 and the height is 6. So that means my area is 1/2 of 11 times 6. So 11 times 6 is 66, and half of that is 33. Okay, so pretty basic example, right? Where I'm just giving you the information you need, plug it into the formula, and simplify, right? Now with right triangles, because remember we did a whole unit on right triangles, sometimes they might, for example, give you the hypotenuse and the base, maybe rather than giving you the height. So you have to use your knowledge of the Pythagorean theorem or possibly of trig in order to find maybe a missing base or a missing height. So that's what I'm going to do in this example right here. So I'm going to draw you another triangle in green. I'm going to tell you that this down here is 3 inches. I don't know what the height is, but I'm going to tell you that the hypotenuse is 5 inches. Okay. Now, some of you may recognize this as a 3, 4, 5 triangle. If you do recognize it as a 3, 4, 5 triangle, you don't have to use the Pythagorean theorem. But for my people that may not recognize this as a Pythagorean triple, you can find the height using the Pythagorean theorem, right? Because 3 inches would be A, the height would be B, and the 5 inches would be C. Right? So I would do 3 squared plus the height squared equals 5 squared. So this is 9 plus height squared equals 25. I'm going to subtract 9 from both sides. And when I do that, I get h squared equals 16. And then I'm going to take the square root of both sides. So I get that the height is 4 inches. So now that I have the base and the height, I can plug those values in and actually find my area, right? So the area of my triangle is 1/2 of the base, which is 3, times the height, which is 4. Okay, so 3 times 4 is 12. Cut that in half and you get 6. And then my unit, because it's an area, is inches squared. So that would be your final answer. Okay. So like I said, I'm going to skip the isosceles triangle / regular polygon because that kind of has its own process and practice problems that go with it. So I'm going to scroll down here and we're going to look at the trapezoid and then composite or irregular figures. Okay. So for a trapezoid, very, very similar to a triangle. It almost looks like a triangle like with its head cut off. Right? So the formula to find its area is very similar to what you're used to here. This trapezoid is kind of on its side, okay? But because it's almost like a triangle with its head cut off, rather than only having one base, it has 2, right? Those 2 parallel lines are both bases, right? So usually we label them as B1 and B2 for base 1 and base 2. And then the height is literally just how tall it is. So that's my height right there. Okay, again, this one's kind of flipped on its side, right? So normally the bases are like on the top and on the bottom of the figure and the height is vertical. It's just this one's flipped on its side. Okay, so my formula for a trapezoid is my area of a trapezoid is 1/2 of, I'm going to add the 2 bases together, B1 plus B2, because I need to include them both, times the height. Okay. All right. So let's do a couple of examples here. Okay. So here's my first example. I'm going to draw you a picture here. Okay, so here's my trapezoid. I'm going to tell you that this right here is 6 inches. I'm going to tell you that this base down at the bottom is 10 inches, and I'm going to tell you this base up at the top is 7 inches. Okay, so that means my area is 1/2 of my two bases are 7 and 10, so 7 plus 10. So that's B1 plus B2 times the height, which is 6. Okay, so my area here is 1/2 of 17 times 6. 17 times 6 is 102. And half of 102 is 51. And then I need my units, so inches squared. Okay. All right. So this is a more typical trapezoid problem because it's upright, right? Where the height is actually going vertically, straight up and down, and the bases are parallel on the top and on the bottom. Okay. So I've got one more example for you that asks you to use your knowledge of special right triangles and of isosceles triangles. Okay, so I've got one more example for you here. Okay. Hold on, I'm really trying to draw this so that it actually looks like what I want it to look like. Close enough. Okay, so I'm going to tell you that this top base here is 11 and the bottom base is 15. Okay, and then I'm going to tell you that I don't know what the height is, but I do know that this distance right here is 2, and I'm going to tell you that this right here is 45 degrees. Okay, all right, and then I'm going to put little markers here just so that you know that this is an isosceles trapezoid, right? Which means that the two sides, the two slanted sides are the same length, okay? So the reason I knew that this was 2, I didn't really even need to tell you that it was 2, right? But I can tell that it's 2 because if the top here is 11 and the whole thing down here at the bottom is 15, I have these little leftover, like hangover pieces on the left and on the right that both have to be 2, so that you have 2, because from here to here is 11, right? 2, 11, and 2 all comes together to make 15, which is the total length of the base, okay? So now my only problem here is I kind of need to know what that height is, okay? But whenever you have a right triangle that has a 45-degree angle in it, that means that this is an isosceles right triangle. So whatever this distance is here, this distance also has to be the same, right? If you watched and learned and looked at the videos on special right triangles, then you know, oh, this is a 45, 45, 90 triangle. But you can also just kind of use your logic and say, well, if this angle is 45, this one also has to be 45 in order for all of these angles to add up to 180. 45 plus 45 is 90, right? And then plus another 90 gives you 180, right? So you have two angles that are the same, which means the two sides, right? The two base angles are the same, so the two sides that are connected to those have to be the same. So since this distance is 2, my height is also 2. So now I have all the information I need in order to find my area of this trapezoid, right? So my area is 1/2 of 11 plus 15 times 2. Okay, and then I'm just going to plug all of that stuff into my calculator, or you can do it in your head, right? So 11 plus 15 is 26 times 2, and then divided by 2. The 2's cancel each other out, so you're left with 26, right? And I didn't give you a unit, so you don't have to give me a unit in answer, okay? This example that I did for you in green is definitely more of like a challenge example, like definitely more of a challenge problem, but I wanted you to see how our knowledge of right triangles especially may end up being used when you're calculating the area of something, right? You had to use your knowledge of Pythagorean theorem in the previous one. We had to use our knowledge of like isosceles triangles, and if you learn special right triangles, that idea, right? So it's important that we keep those things like kind of fresh in our brains, okay? All right, so let's take a look at this last one here, which is on composite figures, okay? A composite or irregular shape is just a complex shape that's made up of simpler shapes, right? So all you really have to do is divide this into simpler shapes. Okay, and for most composite figures, there are many ways to divide this. Okay, but as long as you divide things and calculate your areas correctly, right, then it doesn't really matter how you divide it, right? You're going to end up with the same answer either way. Okay, so for example, right, I could divide this into like this guy hanging out down here, and then I could divide it down the middle so that you have a rectangle and two trapezoids, right? That could work. I could divide this into, say, a triangle at the top and then two rectangles like this here and here. Or you could divide it into a triangle at the top and two rectangles here and here, right? So lots of different ways that you could divide this, right? I'm going to divide it this way just because in my brain, this like makes the most sense. But you could divide it in lots of different ways and still find the same area. Okay, so because this is on grid paper, that's going to help me, right? Because I can figure out what these lengths are. So like from here to here, this side is 2, this side is 3, this height of this middle rectangle is 1, 2, 3, 4, and its base is 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means the base of the triangle at the top is also 8, right? And then the height of the triangle is 2. Okay, so I'm going to find the area of my 3 shapes. So this is my first shape. Whoops, hold on. It's like impossible to see. Let's try a different one. So this is going to be my first shape here. So the area of that first shape is literally, it's a rectangle. So it's just 2 times 3, which is 6. Okay, then the area of my second shape again, just another rectangle. So the area of my second shape here is just 4 times 8, which is 32. Okay, and then the area of my third shape is a triangle. So that's 1/2 of the base, which is 8, times the height, which is 2. So that area, when you multiply all that together, is 8. Okay, so the total area, you're just going to add those 3 together. So 6 plus 32 plus 8, which is 46. Okay, so that's how you find the area of an irregular or a composite shape, right? The easiest thing to do is to break it apart into smaller shapes, right? And then add those smaller areas together. Now, I will say there's one other way that I could have solved this, which is to divide this into a triangle at the top, and then I could have divided this guy into one big rectangle like this. Whoops, like this. Okay, found the area of the whole thing, and then I could have just subtracted this area that's not filled in. Okay, so sometimes when you do a composite area problem, it sometimes makes more sense to find the area of like a big space and then subtract out a smaller area that's like not shaded in. All right. Okay, y'all. So that is it for this video. This was area basics and composite figures, and I will see you in the next one. If you would like to see me do some practice problems with these formulas, check out the practice problems video. But if not, you can skip ahead to the formula video for regular polygons. So whichever video you watch next, I'll see you in the next one. Bye, everybody.